So back to the story. So the symbolists and connectionists. In the beginning, the symbolists were winning. And so the connectionists actually looked pretty crazy. Expert systems were all the rage, especially after they achieved some very public major milestones. So you might have heard of this. In 1997, IBM created Deep Blue, and it was the first computer system to beat the world's greatest chess master. And in this photo, you see that a human is executing what Deep Blue decides to do, because Deep Blue is just software. There's nothing to execute the actual moves. You may also remember this from 2011, when IBM Watson defeated the two best players on Jeopardy. Watson is also an expert system, and so for a long time in the public imagination, this is what AI was. It was these very, very knowledgeable machines. But then something happened. Symbolists started to hit a bit of a wall. Basically, if you want to try to distill all of human knowledge into a simple set of logical rules, it's actually really hard, because you can say, birds can fly, robins are birds, robins can fly. But what about penguins? So there are lots of exceptions to the rules that we have in our world, and it gets really manually laborious to try and discover all of those exceptions and then encode them into the computer. And so symbolists ran into the issue of just not being able to deliver on their promises. It took very, very long to build these expert systems to do anything functional, and the costs started driving up, and funding for their projects went away. And that is when connectionists started to win. So because machine learning is essentially automating away the task of writing rules, instead of manually figuring out what the rules are, you give the machine a bunch of data, and the machine writes the rules for you. It is much faster, much cheaper, and much easier to adapt and readapt to new environments. And so here's an analysis I did earlier this year, which shows the frequency of words changing in AI research papers over time. And you can see that the terms associated with machine learning, like learning, network, data, those basically started to eclipse the terms that are associated with knowledge-based reasoning somewhere around the mid-2000s. So there were two other things that happened to make this shift happen. The first was in 2006, a young computer science professor named Fei-Fei Li came up with an idea. She thought, what if we just drastically increase the amount of data that we feed machines? Then maybe machines will become more capable. And we kind of take this idea for granted today. Everyone says data is the new oil. But at the time, she was ridiculed for it, and it was a really radical idea. So what she did was she began an international effort based on this idea to capture the entire world of objects into a giant open source database of carefully annotated images. So it took 2.5 years. They amassed 3.2 million photos, and that contained everything from animals to people to household objects, whatever you could think of. And Lee called it ImageNet. And then she launched a competition to basically see which team could use this data to then train the best image recognition system. So the second thing that happened is in 2010, another computer science professor named Geoffrey Hinton created a new design for a neural network. So if you remember, neural networks are the software that connectionists came up with to mimic the brain. But when it first came out, it wasn't very good. It was kind of stupid. It only had a few connections and few nodes, only one layer. And so it wasn't very good at processing images. And Hinton came up with the idea of, what if we essentially stack them and create what's known as a deep neural network with many layers? And suddenly, neural networks became a lot more powerful. They were able to process much more sophisticated images. And that's what spawned the subdivision of machine learning that we know today as deep learning, because it's the portmanteau of deep neural networks and machine learning. So both innovations combined led to a dramatic improvement in machines' abilities to recognize images. You can see here, this is a chart of the progress of the ImageNet competition. So in the first year, everyone was still quite far away from perfect accuracy. But in 2012, the first team, which was Hinton's team, used deep learning for the first time, and there was a pretty big leap in performance. So every year after that, through the competition's course, everyone started using deep learning, and very rapidly, practically all the teams by 2017 had reached near perfect accuracy. So this was a very, very clear demonstration of the power of deep learning And what did that do for its popularity? It absolutely exploded. And now we don't just use deep learning for image recognition, as Paul mentioned. We use it for everything. And this is basically the AI hype cycle that we are in today.